In this video, we're going to cover section 10.5 on nucleophilic addition reactions. Now, we just saw in the previous video that we can oxidize an alcohol to a carbonyl-containing compound like an aldehyde, ketone, or carboxylic acid, depending on the starting alcohol and the oxidation conditions that we choose. Now, we can carry out reactions of those products back to the alcohols through a process known as reduction. And the main mechanism that we will look at to describe this reduction process is known as nucleophilic addition. Now, in nucleophilic addition, the carbonyl group is attacked by a nucleophile, and that carbon atom undergoes a change in geometry and hybridization. So as you can see in this figure, our carbonyl carbon is sp2 hybridized, and it takes on a trigonal planar geometry. Following nucleophilic attack, the hybridization of that carbon center will change from sp2 to sp3. Therefore, the geometry will also change. So we'll end up with this tetrahedral intermediate. And this tetrahedral intermediate, as you can see, we generate an oxide from that original carbonyl-containing compound. Now, if a new chiral center is formed in our new tetrahedral intermediate, then a pair of stereoisomers will also be produced. And that's because nucleophilic attack could occur from either side of this plane. As shown, it's from the top side, but we could equally have the probability of the nucleophile attacking from the underside as well. So the general mechanism for nucleophilic addition contains two steps. It's nucleophilic attack followed by a proton transfer. So as we saw in the previous figure, we have the nucleophile attacking the carbon of the carbonyl. In doing so, we have to break the carbon-oxygen pi bond because we can only have, again, 4 bonds to carbon at any one point in time. That will generate the tetrahedral oxide intermediate, and it's from this point that this oxide, acting like a base, will pick up a proton from water. And in doing so, we'll form our new alcohol. And this proton transfer does occur because the oxide here is a stronger base than the hydroxide ion that will be produced after this proton transfer reaction. Now, there's a wide variety of nucleophiles that we can use in nucleophilic addition reactions of carbonyl-containing compounds. But for this course, we're going to focus primarily on hydrogen nucleophiles and carbon nucleophiles. So we'll look at these two reducing agents, or these hydride delivery agents, aluminum hydrides and borohydrides, and then we'll also look at ways in which we can form new carbon-carbon bonds using carbon nucleophiles such as the Grignard reagent and organolithiums. So if you have any questions so far about nucleophilic addition, by all means, send me an email. Thank you.